solving systems by graphing or substitution. So in this video, we'll be looking at what a system is, then how to solve a system. Then we use the method of graphing and also the method of substitution. But first of all, let us look at what a system is. A system of equations refers to two or more equations in two or more variables occurring simultaneously. So that is a system. So an example of a system of equation in two variables, that is system of two linear equations in two variables, is this: y is equal to 2x plus 1 and y is equal to 3 over 2x minus 2. Another example is y equal negative x plus 3, y equal x minus 6. So all these are systems. So this is a system. This also forms a system. Now, when we solve a system of equations, in this case, we are solving two linear equations in two variables, in x and y. Then we have an ordered pair, xy, which is the solution to the system. Being a solution means the ordered pair xy satisfies both equations, or the ordered pair satisfies the system. For instance, 5, 11 is an ordered pair where x equals 5 and y is equal to 11. This ordered pair is a solution to the system y is equal to 2x plus 1 and y is equal to x plus 6. Why? Because the solution must satisfy this ordered pair, must satisfy this system. So let's check to see if indeed 5, 11 satisfies the system y equal 2x plus 1 and y equal x plus 6. So we do a substitution. Y equal 11, so we put 11 here. Then x equal 5, so we put 5 in place of x. That gives us 1. 11 is equal to 2 times 5 plus 1. 2 times 5 is 10. 10 plus 1 is equal to 11. Hence, this mathematical statement is true. Then also, when we substitute 11, 5 into this system, it must satisfy. So we put 11 for y and put 5 for x. That will give us 11 is equal to 5 plus 6. And indeed, 5 plus 6 is 11. So this statement is also true. Hence, we say the ordered pair is a solution. If it happens that it satisfies one and does not satisfy the other, then it is not a solution to the system. So what we just did is just an instance or one case when we have two linear equations in two variables. This is just a case where the solution is unique. That is the straight line that represents the line y equal 2x plus 1, which is this line. and y equal x plus 6, which is this line. The solution represents the point of intersection of these straight lines. So in this case, we say the system is independent and is consistent. The system is independent and is consistent. So because it has a solution, the system is consistent. And because the solution does not depend on any other variable, we say it is independent. Now, other cases also involve, so this is just the case we just talked about, a system that is consistent and independent means that it has a point of intersection of the lines involved being 1. It has a unique solution. Then we have another case where the system is inconsistent, meaning we don't have a solution. As we can see, the red line and the black line will never meet because they are parallel lines, and this system is inconsistent. Then we have another possibility, which is this. In this case, the red line coincides with the black line. So we can see equation 2 lies on equation 1. And this system is consistent, but is dependent, is a dependent system. In other words, there are infinitely many solutions. And for this, we have no solution. And for this, we have a unique solution. Now let's look at an example by substitution. Use substitution to solve the system 3x plus 2y equal 21, 4x plus y equal 23, and verify your solution. To solve this, we need to analyze the two systems carefully and see which of them we can make one variable a subject easily. So we can see that for the second equation, it is easier to make y the subject because the coefficient of y is 1 in that equation. Therefore, we make y the subject or solve for y in the second equation to get y is equal to 23 minus 4x. What do we do next? We substitute y equal 23 minus 4x, hence the name substitution method. So we substitute y equal 23 minus 4x into the first equation because we made that we solve for y in the second equation, so we must put it into the first equation, and that will give us this expression. So this is the first equation. Wherever we see y, we replace with 23 minus 4x. So that will give us 3x plus 2 into 23 minus 4x is equal to 21. We now use the distributive property to expand. So 2 times 23 will give us 46. Then 2 times negative 4x will give us negative x. Now we group like terms, 3x minus 8x. Then we have 21 minus 46. We simplify to get negative 5x is equal to negative 25. The next thing we do is to divide both sides by negative 5 to get x is equal to 5. Now we need to calculate for y. Now that we know the value of x to be equal to 5, we need to calculate for the value of y. So we can decide to substitute the value of x into either of these equations, but it will be faster or quicker to use the equation in which we already solved for y. So we substitute x equal 5 into y equal 23 minus 4x. So what do we do now? Wherever we see x, we replace with 5. And that will give us y is equal to 23 minus 4 times 5. 4 times 5 will give us 20. Hence, 23 minus 20 is equal to 3. Therefore, our solution is 5, 3. Now, we need to verify to see if indeed the ordered pair 5, 3 is the solution to this system. So, what do? We check. Wherever we see x in this system, so this is a system given to us. Wherever we see x, we replace with 5. And wherever we see y, we replace with 3. So we do that substitution to obtain 3 times 5 plus 2 times 3. And we know 3, 5 will give you 15. And 2, 3 will give us 6. Now 15 plus 6 will be equal to 21. Hence, the first equation is satisfied. Now we need to check for the second. 4 by 5 will give you 20. Now 20 plus 3 will be equal to 23. Therefore, the correct answer is indeed 5, 3. Or 5, 3 is indeed a solution to the given system. Let us take one more example. Solve the system by graphing. And the system is x minus 2y is equal to 6. Then we have 2x plus 4y is equal to 12. To solve a system by graphing, we use a graphing software. So for instance, by using the graphing software, we graph both systems on the same graph. And we can see that the two lines intersect at this point. So all we need to do is to read the point of intersection, which is 6, 0. So the x coordinate of this point is 6 and the y coordinate is 0. Hence, the solution to this system by graphing is 6, 0. In our next video to be added into this playlist, we will talk about application problems involving systems. So please do not forget to subscribe to this channel so that if we upload a new video, you get notified. Once again, thanks for watching.